Hello everyone. In the last lecture we have discussed the detailed properties of the beta function and gamma function. So not to repeat, I just wrote the properties here. Beta mn is this. So here m minus 1 n minus 1. You see this is increased by 1. Okay. Then here beta mn is this limit is 0 to infinity. Don't be confused here. Okay. Now this n plus 1, this n is increased here by 1. Then coming to here, beta mn is beta nm is your symmetry property. Okay. Then coming to this type of integral. You know this integral. Now if you substitute 2m minus 1 is p, 2n minus 1 is q. Then here p becomes m becomes p plus 1 by 2. This will be your m and this will be your n. So this is the formula. Now the relation between beta function and gamma function you know. Okay. So now this integral now immediately you get it. So now this integral will be again here half of, this will be your half of this is gamma m means gamma p plus 1 by 2 into gamma n gamma q plus 1 by 2 divided by gamma m plus n means p plus q plus 1 plus 1 2 by 2. Okay. So these are the properties. And also let me remind you the properties of the gamma function, then we'll come to the problems. So likewise coming to the properties of the gamma function, whenever this is n minus 1, this is n. Okay. Then gamma n plus 1 is n gamma n, and whenever f for n is any real number and whenever n is a positive integer, this is your factorial n. Gamma of 1 is your 1, gamma of root over of pi, gamma of half is your root over of pi. Okay. So likewise here gamma of n will be gamma of n plus 1 by n, and you divide it, you will get gamma of 0 or negative integer is your infinity. And one more property you know, gamma n into gamma 1 minus n is pi by sine n pi. So these are the things we have discussed in details in our previous lecture while we taught the beta and gamma functions. Now coming to the most important problems. So coming to the most important problems, one question is 0 to infinity. This it is an improper integral. We will evaluate it. Okay, by using the help of the gamma function, we will evaluate it. You see, so this will be equal to now if you put here x square is equal to t, implies twice x dx is dt, implies here dx is equal to 1 by 2 dt by x. What is your x now? Your x is root over t, so 1 by 2 dt by root over of t. Okay, now you substitute it. So this integral now converted to limit whenever x 0, t also 0, that means here 0 less than x less than infinity. It's same thing as 0 less than t less than infinity. So this integral will converted to 0 to infinity e to the power minus t, and here dx is 1 by 2 dt by root over of t. Is not it? This one. So this is equal to integral 0 to infinity. You can take common half outside. This is your t to the power minus half. Is not it? This is e to the power minus t dt. As I have told you, whatever the power here, is it not of that form? E to the power minus x, x to the power n minus 1. So this will be gamma of minus half plus 1. This half is here outside. So this will be equal to half gamma half. Gamma half is your root pi. So half into root pi. So this is your root over of pi by 2 is the answer. Okay. If it is asked another question, if it is asked integral minus infinity to infinity e to the power minus x square dx, then it is a even function here. You can write it twice 0 to infinity e to the power minus x square dx. So this will be already we got it. So this is equal to 2 into root over of pi by 2. So this is root pi. So this is the Gaussian integral. Now coming to one more question. So coming to this problem, here what to do? Actually in gamma function we have e to the power minus x and x to the power n minus 1. So we need to substitute. Here x square is equal to t here. So you can arrange it here 0 to infinity e to the power minus x square. Now what is its derivative? X dx is half dt, is not it? So we need a x dx here, and to balance it we make it x to the power 3. Okay, then this x to the power 3 will be written in terms of x square. It is 0 to infinity e to the power minus x square into x square to the power 3 by 2. Then 2 cancel x cube, x dx. Now we are ready to apply it. So when you see, when x lies between 0 to infinity, the same thing as here t lies between 0 to infinity. So therefore you will able to write it. So now you will able to write it. This is half x dx is half dt, 0 to infinity. It is here e to the power minus t. It is here t to the power 3 by 2. It is here half dt means dt. Now what I have told you. So this is whatever here power. So this will be here one more gamma of 3 by 2 plus 1, is not it? So what is the formula then? It is 3 by 2 gamma n plus 1 n gamma n. 3 gamma of n plus 1 is n gamma n, is not it? So this is equal to 3 by 2 gamma 3 by 2. Again you can break it. It is 3 by 2 1 by 2 gamma 1 by 2, is not it? So this is equal to 3 by 4 into gamma half is here root pi. So this is your answer. Coming to one more problem. So suppose this is a problem. Okay, in definition we need e to the power minus t. So we have to substitute here 3x is equal to t, is not it? Put 3x is equal to t, right? So what is your x? X is equal to t by 3. So what is your dx? Dx is 1 by 3 dt. So you simplify it in that way. 0 to infinity, your t will be, your x will be t by 3 to the power 4 into e to the power here minus t dt, is not it? So this is equal to, so here dx is dt by 3 here, one more 3 is here. So now bringing 3 outside, 3 to the power 5 integral 0 to infinity, it is e to the power minus t to the power 4 dt, is not it? So it is now of this gamma function form. So now power being 4, it will be 1 by 3 to the power 5. It will gamma of 5. So gamma of 5 is 4 factorial divided by 3 to the power 5. So it is your answer. Coming to one important problem. Integral 0 to 1 dx by root over of minus log x. Or we can write it integral 0 to 1 dx by root over of log 1 by x, is not it? Because log x to the power n is n log x, is not it? So now you substitute this 1 by x is equal to here t, right? Now you substitute, put 1 by x is equal to t. So whenever 0 less than x less than here 1, okay, so what will happen to this? It becomes here infinity less than t less than here 0, right? Now what is the derivative? So actually you put log details. Log 1 by x is equal to t. Okay, so this will remain same here. So now what will happen to here 1 by x? X is equal to here e to the power minus t, is not it? X is equal to e to the power minus t. So what is your dx? Dx is minus e to the power minus t dt. So now what happens to this integral? So this integral becomes minus of infinity to 0. Here dx is e to the power minus t dt. Already I have taken minus sign here, and divided by root over of log x is my root over of t, is not it? This is minus infinity to 0. This is minus of infinity to 0. So now this will be your integral 0 to infinity with this negative sign. So now this power becomes t to the power minus half, and this is my e to the power minus t. So now it is in the form of the gamma function. So this will be equal to your gamma of minus half plus 1. So this is equal to your gamma of half. Gamma of half is your root pi. So this is your answer then. Now coming to one more example, 0 to infinity dx by 1 plus x to the power 4. This integral is quite lengthy by your previous knowledge. So now putting this gamma function here, if I put x square is equal to tan theta, then what will happen here? Tan infinity is pi by 2. So when 0 less than x less than infinity, tan 0 is 0. So implies 0 less than theta is less than my pi by 4. No, tan infinity is pi by 2. So it is pi by 2. So this now you find what is dx. So 2x dx is equal to here. So 2x dx is equal to derivative of tan theta is sec square theta d theta, is not it? So this implies what is your dx? Dx is equal to sec square theta d theta divided by your 2x. Now what is your x? So this is equal to sec square theta by twice x is your root over of tan theta, root over of your tan theta. Now this integral becomes here, this let it be my I. So this integral I becomes integral 0 to pi by 2. Now here dx becomes sec square theta divided by 2 root over of tan theta into 1 by 1 plus x fourth, 1 by 1 plus x square whole square, means tan square theta and here d theta, right? So this will be equal to here, so this will be equal to 1 plus x square theta, tan square theta is your sec square theta, 0 to pi by 2 sec square theta by 2 root over of tan theta into 1 by sec square theta and d theta. Okay, so now your sec square theta cancelled. 1 by 2 integral 0 to pi by 2 sin theta is your cosine theta by cos theta, right? So it is your sin theta to the power minus half, right? And cos will come to the numerator, cos theta to the power here half d theta. Now we get the form here. Now we get the form of the beta function. So half is there, the integral 0 to pi by 2 sin p cos p is your half beta, this minus half plus 1 by 2. So this is minus half plus 1 by 2 is your 1 by 4, and it is half plus 1 by 2 is your 3 by 4. And already I have told you beta this, so this will be 1 by 4. You convert it to gamma 1 by 4 into gamma 3 by 4 divided by gamma m plus n is your 1. Now you apply it. So now let me to remind you this is already known, I have already told. So this sin pi by 4 is your 1 by root 2, so it will be a root 2 pi. So this integral will be root 2 pi divided by 4, gamma 1 is 1. So this is equal to pi by 2 root 2. Okay, so this is your answer. So by using this gamma function, these are quite easy to solve it. Coming to one more example, suppose you are to solve it. Now you split it. So this is equal to 0 to infinite here x square by 1 plus x to the power 10 dx, and this into this, then this into this is this into this, x to the power 6 by 1 plus x to the power 1 plus x to the power 10 dx. Okay, so already I have told you it is 0 to infinity. The formula is right. So this is the formula. So now this 2, it will be your beta of this n will be my 3, and 3 plus what is my 10? 7. So this plus my beta of this is 6 means n is my 7. So 7 plus 3 10. So this is twice beta mn is beta nm 3 beta 3 7, is not it? So this is equal to twice gamma 3 into gamma 7 by gamma 10. So this is equal to twice factorial 2 into factorial 6 by factorial 9, right? So this will be your answer after simplification. Coming to one problem, integral 0 to 1 dx by this. So you put here x to the power 6 is equal to some u, because you need 1 by 1 minus x to the power m plus n. In that way we will think. So x to the power 6 is equal to here u. So that means here x is equal to u to the power 1 by 6. 1 by 6, you note that when 0 less than x less than 1, now x to the power 6 also lies between 1. It's same thing as 0 less than u less than your 1. Okay, so this integral, now what will be your dx? The derivative of this is 1 by 6 u to the power 1 by 6 minus 1 minus 5 by 6 du. So you substitute it here. So this will be your integral 0 to 1 dx. 1 by 6 is taken out. Dx will be u to the power minus 5 by 6 divided by 1 minus u to the power 1 by 6 du. So now this will be 1 by 6 integral 0 to 1 u to the power minus 5 by 6 into 1 minus u to the power minus 1 by 6. This is taken to numerator. Okay, now it is simple the definition of, is it not? Here 1 by 6 0 to 1, here x to the power m minus 1 into 1 minus x to the power n minus 1, is it not that? So this will be my beta of, this will be your beta of this will increase by 1 minus 5 by 6 plus 1 comma it will be your minus 1 by 6 plus 1, is not it? And then 1 by 6 is here. So this will be 1 by 6 beta of 1 by 6 and it is here 5 by 6. Then coming to the gamma, it is 1 by 6 gamma 1 by 6 into gamma 5 by 6 divided by gamma m plus n 5 plus 1 1. Okay, now you use the formula here. Gamma n gamma 1 minus n is pi by sine n pi. So the moment you put n is equal to 1 by 6, put n is equal to 1 by 6, then it is gamma 1 by 6 into gamma 5 by 6 will be pi by sine pi by 6. Sine pi by 6 is your half, it's 2 pi. So this will be right. So this will be your 1 by 6 into 2 pi and gamma of 1 is your 1. So this is equal to your pi by 3. Okay, so this is your answer. So coming to one more problem, 0 to infinity x square by 1 plus x to the power 7 by 2. You put here x square is equal to t. Okay, so your 2x dx is equal to dt, implies here dx is equal to dt by 2x. What is your x? X is root t, so dt by root over of t. Now the thing is that when x lies between 0 to infinity, the t will also never change here. So 0 less than t less than infinity here. So we'll substitute it here. So this is equal to 1 by 2 integral 0 to infinity x square is here t So let me to repeat, integral 0 to infinite x square 1 plus x square to the power 7 by 2. I put x square is equal to t, so 2x dx is dt. Accordingly dx is dt by 2x, so the value of x is root over t here. Now I substitute all these thing here, half, and it is dt by t is for your dx, and it is t by this. Now it will come to this form. Okay, come to this form. Now it is here half, means it is here 3 by 2 1 plus 1, then 3 by 2 plus what is 7 by 2, it is plus 4 by 2, then beta function is converted to the gamma function. Now gamma 2 is this is 1 factorial, and half is half, gamma 2 is factorial 1, and it is 3 by 2. 3 by 2 is half gamma half, and divided by this, and you simplify it to get the answer. Coming to one more problem. Suppose one problem is 0 to pi by 2 root over of cot x dx. Okay, so this will be 0 to pi by 2, cot is cos by sine, cos x by sin x dx. So this is equal to 0 to pi by 2 cos to the power half x into sin to the power minus half x dx. Now convert it to the gamma function, beta function first. So this is same thing as 0 to pi by 2 sin to the power minus half x cos to the power half x. Otherwise it's also okay. We can think this is m and this is a no issue. So this will be half beta of m plus 1 by 2, 2p plus 1 by 2, and q plus 1 by 2, 1 by 4, 1 by 4, it is here 3 by 4, and already we done it earlier. So this is half gamma 1 by 4 into gamma 3 by 4 divided by gamma 1. Already we know this value. So this value is root 2 pi. So this is half here root 2 pi by 1. So this is pi by root 2 is your answer. Okay, coming to the last problem. So coming to the last problem, integral 0 to infinity e to the power 2x minus x square dx. You can write it 0 to infinity e to the power x minus a whole square. If you make it minus of x minus a whole square minus x square, then 2x is there, then plus a square is something extra. So we have a square, we add it here. So it is, if we split it, then it will come 2x minus x square. So now this is being a constant taken out, it is e to the power a square taken out 0 to infinity e to the power minus of x minus a whole square dx. Now you put here, put x minus a is equal to here u. Okay, so when 0 less than x less than infinity, what will happen to u? Putting x is equal to 0, it is minus a less than your u less than your infinity. Then what happens to your dx? Dx is equal to your du. So you substitute it here. So this is equal to e to the power a square integral minus a to infinity e to the power minus u square du. We get a standard integral over here. Now this integral is a standard integral here. E to the power a square is taken out, it is root over of pi by 2. Okay, this is 1 plus error of function f of a. Okay, today at question number 1 we have discussed, you see, at question number 1 we have discussed minus infinity to infinity e to the power minus x square is 2 into 0 to infinite root pi. So now in that line a standard formula is here. The standard formula is right. So you should leave it like this, because this is a standard formula here like this. And if you want to verify the validity of this formula, okay, if you put here a is equal to 0, then what will happen here? Suppose you see, suppose if you want to see the validity of this, if you put here a is equal to 0 here, then it is e to the power 0 is here 1 integral 0 to infinity e to the power minus u square du. Is it not? And if you substitute over here, now what you will get here? You will get here, it's simply root over of pi by 2, right? Root over of pi by 2, so this is okay then. So you should leave it here because of this formula. Okay, so many different examples, all varieties of examples we have solved here. So different examples, different varieties of examples we have solved it here. So I think with this knowledge you will able to approach mostly almost all problems from a standard book. You should go through that. So if you feel this video, this lecture is interesting, and such type of lectures to come out, you should subscribe to this channel so that whenever this new lecture will be uploaded, it will come to your screen. Thank you all. Have a nice day.